Hello. I don't know why I pulled that face. It's a Twitch stream. Let's do the thing. Hello, Sandro Asensio. Nice to see you. You can call me James if you like. Hello, Mountain Ash as well. Yeah, undefined. Undefined is how long. I was looking at a list of commands, and you can do this one, which is !, follow age, or followage. It tells you how long you've been followaging for. And for me, it's apparently undefined. I've been following this, according to the Twitch bot here, like longer than any amount of time. It's amazing. There you go. Yeah, not too bad. Not too bad. I feel like could be. These are pretty small numbers. Is this not? Oh wait, no. There's a 6 months in there that I missed. I saw 22 days. I missed the 6 months. Oh, who else is here? Hi, Herb and Marie's here. Nash, yes. All right, yes. Yeah, Herb, you I vaguely remember. Did you get banned for a bit as a joke? Did we unfollow you so that you could refollow to see if the thing would pop up on screen? You were testing the thing or something. Hey, Maxi. Yeah, okay. Maybe I need to say that they're bigger than 0. That's true. That's 0 to the anything you like, except maybe 0. Let's say that they are positive. This is a question that I saw on the screens in the maths department yesterday when I was in for the open day. Problem of the yesterday. Because it's not the problem of today, it's problem of the yesterday. In the maths department at work, they have a screen that normally has news messages on, or bulletin updates, or something like that, or upcoming seminars. But outside of term time, and it hasn't quite started the summer term yet in Oxford, but outside of term time, it's got problem of the day. And here's the one. I had a quick look at it while I was running around doing the open day, but then after the open day, I thought, maybe I should actually think about this problem. I think I know how it works. I haven't quite worked out the details, but I think I can see what's going on. The idea is, can you ever multiply together 2 consecutive numbers, putting in words, to get a perfect power of any integer to any power? I'm not fussy. I'd be happy if that was 7 cubed or 3 squared or whatever, just when you multiply together 2 consecutive numbers. And the question is formatted so that I know the answer is no, you can't do that ever. The question is to prove that you can't do that ever. Yeah, it's a good screen. Often distracts me. Yeah, do you want not n is... Okay, have you got another workaround where n is 0? Or n is 1? Yeah, okay, yeah. I can see the n is 1, I see. Right, let's go x bigger than 0, y bigger than 0, n bigger than 1. The problem on the screen had loads of these terms and conditions that I haven't memorised. Now we're working out why they're there. Yes, if n is 1, then sure. The question would be, can you multiply 2 numbers together to get a number? Which is the answer is yeah, loads of examples. Oh right, is this? I see. It's a bit like Euclid's proof of infinitely many primes. The idea, that's the one where you multiply lots of things together and then add 1. And it doesn't share any prime factors. And I do want to think about prime factors. So my idea is just, at the moment, I looked up at the screen, squinted at it a bit, I thought about prime factors. To be honest, I thought, well, could these both be powers of the same prime? No, probably not. But that's not quite true. That's not quite what would need to be true. And then over here, I kind of thought, this could be something like 2 times 3 times 4, which is interesting because it's got like these combined together to give a power of 2, and maybe this could be something like 6 to the n. And apparently that doesn't actually happen, and if I go and calculate that, then sure, 24 is not a power of 6, but that gave me pause to think, maybe there's something else going on here. So I'll just leave it on the screen for a bit, and we can chill maths. We can have a go at that question as we, if it's interesting. I've sort of got this horrible feeling that it might not be interesting. that might be it. But You just think about the prime factors and it kind of falls over. Oh yeah, okay, I prefer this. There we go. This looks cleverer. Let's go with this. Hi Charlie, you alright? I've got a problem from the screens that I saw at work. As a kind of problem of the day, but yesterday. Yes, I like this. The left hand side has to be even. I like that a lot. Feels like an actual claim about what's going on here. So the right hand side, oh yeah, this is going to kill it, isn't it? No, this is going to kill it. Cool. In the first case, left hand side is even because it's the product of two consecutive numbers. Either that's even or that is. So the right hand side is also even. And then I think you can say, so y is even. That step is because you're going to get an even power if your number was even. If your number was odd, then you get an odd thing. N's bigger than 1, so y to the n is a multiple of 4. Oh, I thought this would now fall over, but... Can I rinse and repeat? No, maybe not. Oh yeah, sorry, because x could be a multiple of 4. What am I talking about? I was going to try and prove that both x and x plus 1 were both multiples of 2, which would be ridiculous. Yeah, okay. Right, okay, so this thing is a multiple of 4. I did like this idea. I liked this idea. It's a sort of very particular case of thinking about prime factors. So the new kind of idea is just... I've always gone right underneath chat. There you go. I've got to try not to do that. How am I going to avoid that? The system last time. If I draw a kind of... Hang on, if I draw a kind of vertical line, and then I line that up with chat. There we go. Okay. Perfect system, no notes. Just think about two. So I suppose we could look at the prime factors of whatever the not even number is. Because we're now going to be in the position, right, where either x is even or x plus 1 is even. In this case, x plus 1 is odd. What are its factors? And in this case, x is odd. What are its factors? I just think if we can... Yeah, these things have no factors in common, right? This is getting silly, maybe. They're consecutive. They have no prime factors in common. Thank you, cool. So the primes in y to the n, there's quite a lot of primes in y to the n. For each prime in y, you get p to the power of n. All of those come from either x or from the number or in the number x plus 1. So I think that's going to mean you have p1 and p2 maybe, and it's not the case that you get some p1s from each of x and x plus 1. You have to get all the p1s from one of them and not the other. You have to get all the p2s from the other one and not the other, not the first one. The primes are going to sort of split apart. Which means that both of these numbers are powers of n. Gone off the bottom now. Okay, new plan. Draw another line. That sounds pretty silly because powers of n, like 1 to the n, 2 to the n, 3 to the n, those are quite far apart. Yeah. X is a bunch of some primes. Oh, caprice, I've read it. Sorry, coprime, which people sometimes put a dash in, but sometimes don't. It means that they've got no prime factors in common. They might not be prime numbers, but they might be like 10 and... Oh, pick a great example, James, pick a great example. 10 and... I've really frozen on this whole 21. Because although neither of these are prime, they don't have any prime factors in common. That can sometimes be, I guess, important. They've got trivial highest common factor. Different ways of saying the same thing. Prime numbers are always co-prime with anything else, including other prime numbers. But sometimes you get this pair of numbers where they're both composite, but involve different primes. Okay, this looks like a contradiction. I can't do something so merrily in the second case, can I? Because I've got three things now, and this example shows that, right, okay. The primes, maybe two is a special case here. Maybe two is a special case where the twos could split up between x and x plus 2 to give us this kind of special case. And I suppose if I think about powers of 2, it feels like this is going to be 2 to the... Think about a ruler, actually. I think of it like short line, long line, short line, longer line, short line, long line, short line, really long line. By which I mean, if both of these are even, how much does 2 divide each of them? Both even. Are they both multiples of 4? No. Maybe one of them's a multiple of 4. Maybe it's even a multiple of other stuff. But the other one is a multiple of 2, but not a multiple of 4. So, if both even... I thought I was going somewhere with this, and I've just realised I'm not. Yeah, I'm worried this might not be going anywhere. I'm worried this might just descend into some sort of fiddly mess. This is a sort of special case where these both things on the outside are both even numbers, both powers there. Because I was going to say you'll end up with 2 to the power of something plus 1. That's really what I was going to say, wasn't it? You'd get maybe so this is continuing this thought in that direction. Maybe you'd get 2 to the k being a factor of x, or of x plus 2, I suppose, but just 2 being a factor of y, of x plus 1, x plus 2, not 4. And then overall, the kind of number of factors of 2 you've got is k plus 1. I suppose that could be equal to n, so I'm a bit stuck. There might be some other stuff. Problem of the yesterday may have become the problem of many days. Yeah, maybe I do want to divide both sides by 2 to the n. I don't know where the 2's are, though. Where to put them? Perhaps crucially, this thing in here, in the middle, is going to be a power of n for the same reason that these things were powers of n down here. The thing in the middle is odd. In this case, where it goes even, odd, even. The thing in the middle is odd. It doesn't share any factors of 2 with the big even number on the right hand side, but it might share some other primes, and then those primes aren't going to come from either of these neighbouring numbers. So any primes that appear here, we have to take all of them. If there's some multiples of 7 going around on the right hand side, well, which of these numbers is multiple of 7? Maybe it's the middle one? In which case, brilliant. No, nobody else is, and I've got 7 to the n on the right hand side from the power of n over here, right? So I've got 7 to the n, so all of the 7s are going to have to go in there. Once you've admitted that's a multiple of 7, I've got to stick all the 7s in there. Same goes for all the other primes except 2. 2 is the interesting one. So I guess that's 2 cases then. Middle number's odd, middle number's even. Feels like it's a power of 2 in the odd case, in this one here. Sorry, it feels like it's a power of n in the middle case. Like a square or a cube or something like that. And then maybe I'm a bit suspicious. Yeah, a bit suspicious about all these other factors going around. What are the other prime factors here? There's going to end up being like This might not be anything to an n. Yeah, you end up with something like 2 to the k. Yeah, okay, write down all the factorizations, think very carefully about which ones match up. Maybe that kills the problem. I'm not sure. Okay, feeling quite chill. Lots of the problems of the day on the boards are a bit like this, for me at least, where I don't really know any clever techniques or know anything to do. So just try sort of random stuff and hope for the best and see what I can do. I don't know if maybe there's someone out there who looks at the problem of the day and says, aha, yes, this would be a counterexample to the ABC Doublegan conjecture twice. So, can't be true. Should have put it on the whiteboard. Yeah. Should have copied it up, I suppose. I did see it and think, good. That looks like something that people on the open day could have a go at. Sometimes it looks just completely awful, like really hard or really weird. There's been some good ones though. Yeah, Murray. So I was gonna switch. I was winding up to switch now. So perfect timing. That's what I've got. That's what I've got for chill maths. My plan was to switch to step. I didn't stream last week because I was travelling, and I worried that people would think that meant that Cambridge had told me to stop doing this, and they haven't yet. So I wanted to just jump back in and do more step. In particular, what are we going to do? I think I want to jump in on step. What have we skipped some of this, didn't we? We skipped this kind of vector question, and I think I want to try and demonstrate that vectors are nice. So I think I want to try and do the vector question. It's good for me as well. I need to practice my vectors, since that's the most closely related to the sort of thing I actually want to do. Oh, hey, a question. Hello, Iron Mouse. Go for it. Almost Iron Mouse. I'm going to say Iron Mouse. If your question is about maths homework, then people in chat are more likely to be able to help than me. Thank you for the follow. If your question is about step, then I can have a go as well. Let's find out. So I changed one. We're no longer on it. Oh, okay. What does that mean? When were we on a square? Oh. Maybe it's the crop. Oh, 169. Yes, that's right. I had a joke lined up for that I forgot to do, and now we're at 170. Next sub goal is going to be it's like a difference of 2 squares for the. I'll have to wait until we hit the next square number. Oh, you're going to answer. Right, great, bro. Yeah, okay. we have a long-standing sub follow goal of, is it subs or followers? It's not subs, is it? That would be mad. We have a long-standing follower goal of 196 following a tricky episode with the number 14 and some squares. We've been going towards it until Herb unsubscribed. So Herb's unfollowing again, I think maybe. We just hit 169, which is the previous square number before 196. So difference 2 squares. I can't demonstrate the theorem of Cantor-Bernstein, which, oh gosh, rings a bell, but oh my goodness, good luck us. Thanks for the follow up. That's reset your followage, doesn't it? Oh, thanks, bro. What a wind up. Let E and F be sets as assumed there exists both an injection and a surjection V in F. Show that there exists a bijection from E into F. Let me think. Is this a thing we can Google? Oh, maybe Google's cheating. You know the name of the theorem. Yeah, I'm really juicing the numbers on those follows. E and F. There exists an injection and there is a surjection. I suppose there's only interesting for infinite sets, boys. We've just sort of counted them and checked that it's the right number. Yeah, that's the quote. That's the quote, Charlie. Yeah. Why would that not be true? So you want injection from E to F. It's not very simple. Well, the homework where it's complicated to demonstrate. What sort of level do you think it is? My impression is that you've got to demonstrate an explicit bijection. I don't know any other theory really in this field for proving that things have a bijection other than constructing one out of the ingredients that you've got. I'm nervous because you haven't got very many ingredients. I'm gonna Google it. We're learning maths today. It's a result from set theory. If there are just injective functions both ways, there's a bijection. And there's a complicated proof with loads of arrows on Wikipedia. Oh my goodness. Ugh. Would I have thought of this? No, I would not have thought of this. This is very clever. Good, okay, good. Person in chat. I guess. I guess the challenge is that you have your surjection. That seems like a good place to start, and then you kind of want to choose an element of the pre-images. Feels almost like a fixed point thing, but not quite. Let's go backwards. So I think you want to construct a new map that's neither of the existing things you've got, and construct it so that it's both. My first step, I think, and you've now told me it's hard, and I've also looked at somebody else's proof to check that it's hard. So I'm not sure how much time I'm going to spend doing this in my head. But my first step, I think, would be to draw a map of what surjection looks like. And then to make that a bijection. Oh, this is so weird, isn't it? It's a bijection. It just feels like it's impossible again. So you've got your surjection. But there's also an injection. I almost want to choose. Yeah, so can you use this as a kind of focusing thing that if you take the, I don't know, if you take the pre-image and you take the pre-image again? No, maybe you take the image and then the. You can kind of map both ways because you've got an injection and a surjection. So if you map both ways, you just need to make sure that you're constructing an image of each point and that you don't. I don't know. Sounds fun. I'm going to do this question now. Let's go. Okay. If people are watching for a step thing to happen, that's what's going to happen now. Okay. A and B with respect to an origin O, and A and B are not collinear. Okay, good. A and B are not multiples of each other. The point C with precision vector C is the reflection of B in the line through O and A. So what do I want? I want a better diagram. I want something that goes over there. I don't want to call that O, I want to call that C. I'll find out where C is. Okay, so what is that? There's a point over here, which is some unknown, I don't know where this is. There's a point here at, X, I suppose, but X is a multiple of A. I'm going to use mu because lambda is something in the question. So I'm going to say I've got this point over here. I suppose I do know what this is. I suppose that this is B dot A. Lambda's specified in the question. B dot A divided by B dot B. I think. Do I want a square root there? Can't remember how projection works. This is why we're doing revision. So there's this way where A dot B means the size of A, the size of B, cos theta. It's one interpretation of what A dot B is. But what I want for this distance, I suppose. Oh, can I just make everything a unit vector? That would be so much nicer. These are dot products, yes, for the dot in between. So dot products between two vectors, just to be clear, defined like this. I don't know if we're in 3D or not. If we're in 4D, we keep going, but hey. Okay, they're cool. They're cool. I'm considering turning everything into a unit vector. I'm regretting everything I've written down so far. This is fun. Okay, so this point x. I kind of want this distance, which is size of b cos theta, and the direction that I want to go in is a. But actually, I know the length of this, so it's in the direction of a with a distance of mod b cos theta, which, if I remember that mod a mod b cos theta is a dot b, I think I get this. So then C would be at the point, so C is opposite, so I want this vector. So how do you get from 2x from B, and then go that far again? So that's something like C is it's like B, but plus twice x minus B. It doesn't look like I'm going to get the right answer, but we're trying, so that's a good start. I get the right B, don't I? I get 2x minus B, and then I'm not quite there. I've screwed up my A's somehow. Oh yeah, this is squared here because I introduced a mod A upstairs. I should introduce a mod A downstairs. Algebra. Okay, so this is going to end up being 2 times this vector, which is, 2 times this vector, which includes an A. I've got one of those, and it includes 2, I guess, A dot B divided by mod A squared is A dot A. For Charlie's benefit, this is cool because if you put the same vector in twice, you get the sums of the squares of the components, which, like a Pythagoras kind of thing, gives you the length of the vector squared. I mean, maybe that's not cool, that's just a more complicated thing that reduces down to something you recognise in this case. The more general thing is if they're different vectors. If they're different vectors, then you get the length of the first one, the length of the second one, and this cosine theta, where theta is the angle between them. This is useful because it gives you a relationship between angles and things that are easy to work out with vectors. Especially if, some people get really into dot products and start, whenever you see this mod A, you think, aha, A dot A then square root it, which is maybe a weird thing to think when you see this B and you think, aha, B dot B then square root that. So some people get really excited by this and define the angle between two vectors in terms of this relationship. And you should take your 2 vectors, work out A dot B, work out A dot A, work out B dot B, and then there you go, there's the formula for cos theta, which maybe feels backwards. Yeah, there's a interesting that you've learned determinants before dot products. They're really useful. It's the thing that you do when you do matrix multiplication. So you have a row of one matrix, you have a column of the other matrix, and you dot them together. You do that zipper thing where you go along the row and down the column, multiplying all the numbers together and adding the things that you see to get your total. That's a dot product between that vector and that vector. Yeah. Oh, okay. If you've seen Matrix Multiplication or other stuff as well. Cool, right, I made a meal of this. I think this is probably only a couple of marks, and I really, off to a cold start on here. And I haven't proved that that surjection-injection thing went round back in a loop to become a bijection. I did look at the Wikipedia page, though. Okay. Point D is the reflection of C in the line through O and B. Oh my goodness. So I think this is the same thing, right? I'm just repeating this, but with all the letters changed. This is dangerous. I'm going to try an advanced move where I take the previous result. Oh, this is going to go so badly wrong. Take the previous result and change the letters. This is going to go terribly. I'm smiling because it's such a stupid idea. So our previous result said, gosh, to reflect B in A, you end up at 2 A dot B A divided by A dot A minus B. And now we've been asked to reflect C in the line through O and B. So move is going to be like this. Instead of B, we now have C. And instead of A, we now have B. This is dangerous because if you do the swaps, I sort of want to swap those letters, right? The point that's being reflected is no longer B, it's now C. And the point that we're reflecting, the line that we're reflecting in is now the line through A. It's now the line through B rather than the line through A. I'm so confused already and I haven't even started. Let's go. So I'm going to write down that expression from before. So similarly to before, the point D is going to be dot together your new vectors, dot together the two vectors, divide by the one that's all about lines, dotted with itself. Write down the one that's all about lines, minus, and then instead of B, here's the temptation, I write down C for this new one. I think. Yeah, pretty happy with that. Okay. So replacing kind of all the B's change to C's, all the A's change to B's in that order. If you do these switches in sequence rather than at the same time, then things are going to go badly wrong. You'll end up with a whole bunch of C's. 1, 2, 3, 4, 5. So many C's. Okay, what is this? Well, this C in here, we actually have a relationship for that. So if I read this line, no switching, I had a relationship right there. That's equal to lambda A minus B. So I am going to end up with this negative lambda A, and then my mu coefficient here on the B vector is going to be 2 B dot C divided by B dot B. And then don't forget over here plus 1 from this kind of minus. Arrows everywhere. There we go. Good. Zoe's trying to learn C++. Something I've never tried to do, but I sort of think that's a character failing on my part. That I should know a proper programming language, really. I'm not going to drop the stream and start doing C++ though. That would be fun, wouldn't it? If you dropped C++ to do the stream and I dropped the stream to do C++. I'm doing a step question, sorry. It's going all right. I had a very cold start. Did not get my tyres up to temperature, but then eventually we got some warmth in. Everything got a little bit easier. We've just been switching letters around. Oh no, they don't accept JavaScript. What is this? What are you doing? MIT Programming Tournament. Let me look up this MIT Programming Tournament. I've got more followers than me. Oh no, that's the thing I've just looked at. It is a basketball tournament. You did not mean this. Is this a thing that you can Google? Hang on, I'll put in code. Battle code. No, I don't think it's that. Anyway, never mind. Okay, this is not a thing that you can Google. It's called MIT. MIT. They only accept Java but not JavaScript, Python and C++. Do they accept MATLAB? If so, I can help. Or like really janky Desmos. Oh, maybe Fortran if I have to. It doesn't sound like I can join in here. Not a game for me. Right, okay, we've got a scalar mu. Does it? If you Google MIT Programming Tournament, this is great. I can get chat to do the Googling for me. Hang on. See if I can verify that on my machine. Programming. What's the keyword? Oh, MIT. They have a cute logo. Let's all look at the logo. Ugh, this countdown timer says that Zoe's got 3 hours. Adorable. Oh, questions. This is lovely. I'm enjoying this website a lot. Oh, they're sponsored by Jane Street. All the best things. Decided not to sit the step for fun. Right, good. Okay. Thanks for the side notes. I think it's good for me to see other stuff that's going on. Just take some ideas. One of them's got a trophy. Are you saying that I should get a trophy? Or a hoodie? I can do one of those. Okay. Given that, okay, last part of the question. Look, we're here. We've got 2 lines to go. We can do it, chat. Given that A, B, and D are collinear, and I've now completely abandoned my diagram, which was never that good. One of the nice things about vectors is that you can kind of just work with them without drawing the pictures and the angles, as long as you remember the vector facts, which I was having trouble with. Given that A, B, and D are collinear, right, what have I got? I've got the vector A, I've got the vector B, those were original things, and now I've got D is equal to mu B minus lambda A. So what does it mean for A, B, and D to be collinear? I suppose it means, I will draw a little picture, A, B, and D. I suppose it means that D minus A and B minus A would be multiples of each other. So D minus A would be, I don't know, some multiple of B minus A, which seems reasonable. Let's turn the handle on that and see what happens. I think that's a condition for them to be collinear. Yeah, it looks good. You should take the B minus A vector and just multiply it by some scalar. I don't mind. I don't really know what that would be, but we can find out because we know where D is, I think. So it's be B mu minus lambda and minus another one A, BK, B minus A. So then I think A and B are not collinear. So these are genuinely different things. So I can compare coefficients of B and A. So I think I can say that mu is equal to K and lambda plus 1 is equal to K. Okay. So I have find the relationship between lambda and mu. I should plug this in here. Hooray. In the case that lambda is minus 1/2, mu is 1/2, determine the cosine of AOB. This is something to do with the cosine fact that I told Charlie at the start. The cosine fact I told you at the start, which is A dot B, has got something to do with these things as well. Describe the relative positions of A, B, and D. See, that actually sounds hard. So let's go and do that. Okay, in the case lambda is minus 1/2. So it's so kind of weird and technical, right? That lambda, if you try and think about it geometrically, is the coefficient of A up here. It's the distance that C isn't, because we're really talking about the point X. So the distance that C isn't in the direction of A is minus half the length of A. So it's the other way, half as much. And then B is reflected through that point to C over somewhere else. Where's D? Good luck. This is the trick is to not do these questions with any geometry, but to just bash through your vector facts. Let's think about comparing coefficients. I wonder if anyone's going to challenge me on that in chat. We'll see in a second. Right, where am I going? I think I'm going to go through and plug in lambda as -1/2. Do I? Not really. Not really. Can I do better than this? So when I said that mu is... So if I know that lambda is -1/2, something I notice is that mu becomes 1/2 in here. 1 take away a half is 1/2. So if I've got mu is 1/2, say mu, I think. Oops. What can I deduce from these facts? It's kind of the rest of the question, I suppose. If I follow this through, I would have C would be -1/2 A minus B, and then D would be 1/2 of B plus 1/2 of A. Oh, it's the average of A and B. D is the midpoint of A of the segment AB. D midpoint of AB. Okay, that's pretty cool. I knew it was collinear because we're in that case. Oh, I suppose, am I in this subcase? Oh, whatever. I think I probably am. Yeah, anyway. I think this all runs together in one paragraph, so I'm assuming that's a kind of subcase of this collinear fact. Everything is as described in the question so far. Wobbled a little bit about whether I'm supposed to sort of start again, but just with the information that lambda is -1/2 and nothing else. But then I've got nothing else. I've only got one scalar and no vectors to play with, so we'll stay there. Okay, I haven't really thought about what C is yet. Let's keep going. I haven't found cosine of AOB yet either. Maybe that will come through somehow. So I haven't yet used the fact that this lambda has this meaning over here, that -1/2 is equal to 2 A dot B over A dot A. Seems relevant. So I know that A dot B is minus, this is a bit weird, -1/4 A dot A. And I've also got this fact about mu. I knew what that was, and I haven't used that yet either. 1/2 of... And this is going to be a little bit weird, isn't it? Because this is 2 B dot C over B dot B plus 1. B dot C, though, I could have simplified this before, because B dot C is lambda B dot A minus B dot B over B dot B. Oh, and that cancels to +1. So it's 1/2 A dot B over B dot B. So I think this is not quite because of the minus sign. So A dot B is -1/2 because of the lambda. Yep. Lambda is -1/2. Yes. -1/4 of B dot B. Which I think means that mod A and mod B are the same length, because I've now got these two facts from all of the stuff that we did before, plugged into this special case. I think mod A is equal to mod B. Oh, we had this before. I just don't know how to ban people. I should work it out. No, 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 no. Don't do it in here. I've not worked out it. Yes, did it. Okay, I've worked it out. This is an exciting Twitch adventure where banned in James Monroe by James Monroe. I did it. Da 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 da. Learning to Twitch stream. I'm worried that all that did really was just draw attention There's a good minute or so of the stream being interrupted and me going, oh, how do settings work? Oh no. Followed by celebration and people repeating the username. I don't think the username's the relevant bit. I hope nobody clicked on that URL. Good. Okay. So, this is a moderated Twitch stream. It just happens to be moderated by me. These vectors are the same length. We'll stay on track. It's like being the captain of a ship where the ship is very easily distracted, the captain is very easily distracted, and we're sailing where we want to. What is going on? The vectors are the same length. What? So what? What does that tell me? What do you want me to do with this fact? I don't know what's going on. Help. So probably what I would do now in this step question is to just keep turning handles and cranking through. And what I would not do is stop and think about what on earth I'm doing. And maybe it'd be good for me to draw a picture, because I never draw a picture. I always just keep plugging things into each other. So I should draw. What should I draw? I now know that A and B are the same length. So I should draw something with A and B the same length. And with D the midpoint, because I know that as well. And C is somewhere over here. Now I've drawn this way too close to 60 degrees, so this is going to look rubbish, but C is somewhere over here. And it's the case that that's the reflection in that line, so right angles, equal length lines, and then C got reflected in the line through B to give me D. Oh, this is nuts. Oh, I don't understand this at all. My picture doesn't look like what I was expecting at all. Which is interesting. Let's try drawing a different picture with a wider angle. Because then maybe C is the reflection of B in the line through O and A. Oh, in the line. So if this angle is bigger than 90 degrees, if the angle is bigger than 90 degrees, then it could go over here somewhere. That's further away. It could be over here somewhere, and then eventually get reflected in that line. Oh, this is so weird. I can't make this work in my diagram at all. So maybe I've done something wrong. That'd be fun. Okay, let's jump back in. What am I going to check? I'm going to check my algebra in this bit here, because I don't think I was doing this bit very carefully. I didn't know it was going to be... I didn't know that it would be... I didn't know this bit would be important, but it now feels like everything's hinging on it. This is, I agree, not a good way of convincing somebody that vectors are good. I was hoping there'd be more dot products and fun stuff going on in here. Maybe there could be more fun stuff going on if I was being cleverer. Okay, what are we doing? Could we just define a... Yeah, so everything is happening in the plane. So we could do everything as a 2D geometry question, or a 2D coordinate geometry question if we wanted to. My gut feeling, and I guess some experience, is that that gets very messy very quickly. So I think I want to tidy this up first before I give up and go to 2D geometry. 2D vectors, I think you can just assume that everything I'm doing is 2D. Hang on, let me just cross out these threes, and now everything's a 2D vector question. I do my 2D vector questions like this as well. What is going on here then? So d minus a is k times b minus a. And then I wrote out what d was. It's mu b minus lambda a. Let's tidy up a little bit. Mu b minus lambda a. And I have, why have I done that? Yep, because I've also subtracted an a. So that's k, b minus a. So comparing mu is k and lambda plus 1 is k. So I don't know what k is, but lambda plus 1 is mu. Good. If lambda is minus 1/2, then mu is 1/2. And then I interpreted that in a couple of lines, just picking out random lines, minus 1/2, that's 1. Didn't do anything with that. But D, I recognised, gave me the midpoint of A and B. I guess that says that K is minus 1 in this case. Because, oh no, K is 1/2. Because D is actually between A and B. So my little diagram here, D is 1/2 of the length of the vector A to B. K is 1/2. Good. Okay. D is the midpoint of A and B. Then we went and tried to try and work out from these mu and lambda things what A dot B is. Because then I think we're basically done if we work out A dot B. But it hasn't been plain sailing because I can't rearrange these things right. I can't get a kind of, I want like a number on the right hand side. What am I missing? What am I missing? This is 1/2 A minus B. I haven't done anything with that line with the question mark on it. I guess I plugged it in down here, didn't I, to analyse this thing. I keep reading then. 2 b dot c over b dot b. And then that's c. I've used the fact that it's lambda a minus b, which, I've lost a factor of 2. No, there's a, oh, I think I've lost a factor of 2. This is fun. I've lost a factor of 2 in here somewhere. I've lost a factor of 2. I need a factor of 2. I'd like, oh, all right, okay. So this b dot c, I was doing too many things at once. B dot c, use that c to get a lambda a dot b, and to get a minus b dot b. And I kept the plus 1, but I've lost a factor of 2, which changes everything. Back in. Finding a mistake like that's so good, because now all the crazy things that I was thinking are less likely to be what is kind of actually going on. The fact that there's a 2 here changes stuff quite a lot. Because, for example, it means that this becomes, well, so it means that 1 doesn't cancel anymore because it's now minus 2. I'll put the minus 1 in, and this 2 out here is going to cancel with that factor of 1/2. So this is only be 1/2 b dot b. Okay, so b dot b is nowhere near as large as a dot a anymore. Or twice as big. I'm getting confused with my fractions, sorry. B dot b is half of a dot a. So I think the size of b is the size of a divided by √2. So it's totally different to what I was doing a second ago, where I was trying to draw those isosceles triangles and it didn't feel like it worked. B is shorter by a factor of √2. A dot b is definitely negative because this thing is a square. How can I not know what this is? So it sort of feels like it's size independent, right? Show the formula for A dot B. Oh, yeah, okay, so you take, I scribbled out some of it. You take A1, B1, A2, B2, and A3, B3. But then, fun fact, this is also the same thing as the size of A, the size of B, cos theta. So we're almost there, really. We have 3 unknowns. I don't know the size of A, and then I don't know the size of B, and I don't know the angle between them. I'm never going to work out. This is why the coordinate geometry is a little bit tricky, because I'm never going to work out where around this is relative to the x-axis and the y-axis. Total brain block as well. I've got any ideas. He says writing down an idea. That's 2 equations. Where's my 3rd equation? Ah. Yeah, I previously thought that mod A was mod B, but that was incorrect. I also don't know the value of this thing before I try and divide. Yeah, cos theta is A dot B divided by mod A mod B. Hi, Super Snowman. Zoe's put a comment about talking to a physicist with a PhD at Chess Club last week, and they said that PhD is mostly an attendance degree. It isn't easy work, but as long as you actually do it. Isn't easy work, but as long as you actually do it. Pretty impossible to fail your Viva. It's an interesting take. I think if you get to the Viva, if you've done it, and you've done some work, and you've written it up, and you get to being examined and having the Viva, then I think you're quite likely to get the PhD. I think there are lots of people, though, maybe not most people, but there are lots of people who don't get that far, who, for a variety of reasons, don't get to the bit where you have a Viva at the end. It's true that the Viva itself doesn't quite feel like a pass-fail driving test kind of exam. But there is definitely some attrition along the way. I don't know if that's fair to call it attendance afterwards, after the fact, but in mathematics, the amount of progress that you make really depends on what sort of problem you're working on. And although there's no sort of accepted minimum amount of progress to write things up as a thesis, it, I think, strongly determines how long you spend doing a PhD. It's how much progress you're making. And there are loads of things that affect that are outside of any individual's control. Start realising it's not going anywhere and you need to do something else. Yeah, that can happen. That sounded like a notification, but it was actually my computer telling me that something's good or bad, or I don't know. Now I'm thinking about PhDs. I'm trying to work out what on earth am I doing with all these mod A's and mod B's? Well, what was I doing? I've gone out of my mind for a bit, come back again, and I've just found the room full of lambdas. Who put all these here? D is still definitely the midpoint of AB. What on earth is going on? None of that's true. Dear. None of that's good. But D is definitely the midpoint of A and B. It's just the case that B is a little bit shorter than A. So how did this happen then? B got reflected in A to give us C, and that point was somewhere kind of, the reflection kind of happens behind. Just C somewhere over, I want to draw it more over here. I just can't imagine this happening at all. It doesn't seem possible. Maybe I keep drawing this angle too small, and the angle's actually huge. Maybe that's the punchline. What on earth am I missing? Guess it's -1/2. Don't know, might have to come back to it. That's annoying. Oh, can I just, is it something like just from the first bit, right? That lambda is -1/2 does that tell me about the angle way back up here? that relationship between A and B. It feels like, yeah, maybe that should just be it, right? Because it scales weirdly with the length of A. It scales so weirdly. When someone tells you that lambda is -1/2, well, I kind of take it, that should tell you what A dot B is, but it kind of depends on mod A. This unfortunate way. A and B are not collinear, and they stay. Not sorry. O, A, and B are not collinear. The 3 points not collinear. Later on, A, B, and D turn out to be collinear, but at no point are A and B collinear with O. The whole thing is 2D. So even if you choose A and B as 3D vectors, all of the action happens within a 2D plane containing O and A and B. So it's kind of no difference between 2D and 3D. The 3D version of this problem, the things you specify all live within the same 2D plane. So it could be in 4D for all it matters. The kind of extra dimensions aren't doing anything. Okay, so it feels like at this stage, being told lambda is -1/2 doesn't specify the angle, and it's only when it's later I've followed through and it's turned out that D has landed perfectly back on the midpoint of the original segment AB that I learned something. Thank you for the follow, Ambivalenton. Ambivalenton? I don't know which syllables to stress. Thanks for the follow. Gosh, what am I doing? If you've just followed me trying to do a step question, which I thought I could do, but it turns out there's a sting in the tail, and right at the end, we're trying to find the cosine of a particular angle. We've had the points A and B, they've been with us all along. It's only right at the end that we've discovered the horrible truth that after doing a reflection and then another reflection, we've ended up at the midpoint of the segment we started with. Which I'm not really enjoying because I haven't yet been able to draw a diagram where that feels even slightly likely to happen. Yes. Let's try some stupid things. Yeah, I'm bored of doing sensible things. Let's try some stupid things. What if it's like a right angle triangle, right? When I saw this root 2, I thought, maybe this is like a right angled isosceles triangle thing. Let's just see if that's good. It won't be good, but we're going to try anyway. So which way around is it? We knew at some point that A dot B is no. What on earth do I know? What on earth do I know? You got all the questions here. B is shorter than A by a factor of root 2, so maybe it's like this. Where sneakily this is like right angle equal. Oh, that's an example where B is like 1/√2. Let's see if this does anything interesting. So we're asked first to reflect the line B in the line through A. That takes me down to the other corner of this square over here. And then we're asked to reflect the line C in the line through O and B, which takes us over here. Which is notable for being neither collinear nor anywhere near the midpoint of A and B. Do I really believe this midpoint thing? It's sort of derived from some random algebra that we did a while ago. 1/2 and 1/2, yeah. Lambda's a half. Lambda's -1/2. Mu is +1/2, yeah. The average of A and B. Okay, so that didn't work. Can I adapt this idea? What if it's like this? This is so cheeky. This is not how any of this works. I'm going to keep trying stupid triangles. Okay, I've built myself a diagram like this. It's still the case that B is over here and A is over here. I still don't really believe this works. This happens. It's now 135 degrees. Here's what we're going to do. We're going to reflect the line B in reflect the point B in the line through O and A to get down here. And that was -1/2 of A, so that's a good start. Interesting. Okay, And then we're going to reflect C in the line through O and D. So I want to draw in loads more triangles, I think. Oh, this is the stupidest thing I've ever done. That's not true, I've done a lot of stupid things. Reflect C in the line through O and B, which is this line here, which will take me over here. And this time D is on the other side of AB. It's closest to the midpoint, but it's not quite there. So there's something in between, some crazy point in between where, oh, hang on, have I done something stupid? He says, having always done something stupid. Yeah, a bunch of right angles and 45 degrees. I think we're good. How long do people have? About 45 minutes. Half an hour, 45 minutes for a step question. I don't know how long I've been doing. About 45 minutes, isn't it? Bit of chat. Bit of lack of focus. Also, I'm being an idiot about it now and just trying to cheese it by guessing the angle, which is not encouraged. Mentally, I think I've given up. Oh, that's sad though, isn't it? We're not quitters here. Okay, so what's the difference between these pictures? Lots of things. Should we do another question and come back? Oh, I see, that's very sensible. It's a very sensible thing to say. Work backwards. Work backwards. Didn't work backwards. Didn't work backwards. Reflect A. B and I through O and A. Yeah, nonsense, rubbish, terrible. Try to use vectors. Yeah. Okay, we're not giving up. We are trying a different question. Which one are we going to do? I can't remember which ones we did last time. Did we talk about this one last time? What would I do in the step exam? I'd do something different and come back. Let's do... What am I going to do? I think I'm going to do this one. We mentioned it briefly last time. We talked about a step question, but we didn't do the question. I need to find a way to stop that from happening. Could be stats time. Let's do stats time. Stats time. Woo! Here we go. Oh. X and Y are playing a match, a series of games. Each game consists of 3 points. X wins with probability P, and Y wins with probability 1 minus P of winning the first point of any game. In the second and third, the player who won the previous point has probability P, winner's advantage or something, with X having the winner's advantage sort of thing at the start. And then one who lost has probability 1 minus P. If a player wins 2 consecutive points in a single game, the match ends, the player has won. Otherwise, the match continues with another game. A single game, the match ends. Points in a single game. Each game consists of 3 points. I was not paying enough attention to the fact that there were match games points. Here we go. First point of any game. Second and third points of each game. Break 1 previous point. What happens in a game? Oh, okay. So the game might get to 3. Game consists of 3 points. Is it best of 3? If a player wins 2 consecutive points in a single game, the match ends. That player has won. Otherwise, they continue with another game. Okay. Series of games. Okay, few. Okay, so maybe the game is inconclusive. Nobody gets 2 points in a row. Gosh, that was hard to read. Don't recommend this activity, by the way. It's trying to skim read a paragraph quickly on stream and then missing all the details. Words. Okay. And we're just going to calculate the probability that Y wins the match. So let's look at the first game. Yes, so each game's the same, I think. If there's a difference between the games, then I've missed it. So, consecutive point in a single game. Eunice wins the match. So Eunice wins the first game. No, let's work out what happens in a game. So in a game, the winners might look like this. I guess there's 8 outcomes. And I'm going to try and evaluate what the probabilities of each of these things are, which I hope is not too hard. So X wins the first one with probability P, so this is outcome, and this is probability. And then if you win, the probability you win the next one is P, and then if you win, the probability that you win the next one is P. Player who won the previous point has probability P. Okay, whereas here it's P because X wins first, and then P for X to win again, but then Eunice overcomes that for a 1 minus P to keep going. And we're going to have to analyse what this means for the match in a second, but I think I can run through these in terms of what the probabilities are for the first thing that happens. It's 1 just off the screen there. And then what the probability is that the other person wins. No, that was a switch for those two. So these two see a change of winner, and then this last one would be the same person winning again, different person winning. This is the least likely thing to happen. Probably, maybe. I'm imagining that P is a large number, and that's a change of winner, and that's the same winner again. Okay, whoa. Yeah, there's going to be a sum of a geometric series in here, right? So overall then, what does this mean for the match? And there's kind of 3 things that can happen, right? In some of these outcomes, it's just over. X wins match, and I mean the whole match. That happens in this case as well because X won these 2 points in a row. Some of them are inconclusive. Looks like 2 of these are inconclusive. 1, 2, 3, 4, 5, 6. My outcomes don't quite line up. And some of them are actually good for Eunice. This is the one where X surprisingly loses the first round in a shock upset, but then surprisingly comes back to win both points in this game. I'm trying to use the words so that I learn what the words are. It's going to be an infinite geometric sum in a second, because then we've got kind of 3 outcomes for the game. Either it's all over, and Eunice did win, hooray, or it's all over and X has won, disaster, or we play again. So, here we go. And okay, so maybe I'll draw a quick probability tree for what this looks like. It's actually a Markov chain, but let's not talk about that right now. So there's a probability. Oh, I guess I'm going to have to add these things up. Oh, I don't really want to think about that. I'm gonna use a letter for now. There's a probability A or something that X wins. There's probability B that Y wins. That's probability C that we play again. And if we play again, there's probability A that X wins, a probability B that Y wins, and probability C that we play again. And then keep going, and we get to X, and then a Y, and then oh my goodness, we keep playing and keep going again, off the bottom of the screen. So the probability that Y wins the entire match with probability, and my A's and B's and C's I should relate together back to what those were, but this infinite geometric series that everybody's predicted in chat is something like, in my notation, B plus C, the chance that you have on the go and win the second one, plus C squared, maybe you win on the third point of asking, or maybe you keep going, and that's a geometric series. So we need to work out B over 1 minus C. Does this look like it could be B over 1 minus C? Maybe. Yeah, cool, I agree. Maybe this could be in something of the form b over 1 minus c. Looks a little bit good. Looks as if it could. Okay, so in my notation, b is something like the probability that Eunice wins any given match, which I can see some of these. Let's almost simplify this a bit, don't I? And I'm going to regret the way that I have laid these out because there we go. Terrible handwriting fail. P squared 1 minus p plus p 1 minus p 1 minus p. Oh, I'm being silly. These two add up to p1 minus p. Plus there's also this p squared 1 minus p. There's some adding that I can do here. I'm using the fact that p plus 1 minus p is 1. I've got p 1 minus p for this term, and I've got p squared 1 minus p for this term. So I think this actually collapses down quite neatly to be p minus p squared plus p squared minus p cubed. So p minus p cubed. Huh. So what was I expecting? Not quite. There's a 1 minus p squared up here. Maybe I'll get a factor of p down here. It's not impossible. Because c is the chance that we go again. It's kind of inconclusive one, which is p 1 minus p squared plus over here. Oh, my alignment is awful. 1 minus p cubed. Which I see is something nice because that's going to be 1 minus p squared. Yeah, okay, the p's are going to cancel. It's going to be fine. So now simplify this thing here. Becomes something like p 1 minus p squared from this b term over here, and then I need to write out 1 minus c. But when I say the p's are cancelling, I can see because these 1s are going to cancel, and there'll be a 2 down here as well. So just writing behind my camera now. 2 minus p, cancel the p, 1 minus p squared. Excuse me. Oh good, we achieved a thing. Phew, it's been a while. Okay, we got loads more. It cancelled down nicely, didn't it? Oh, it's really simplified. I love it when that happens. Maybe there's a good reason for this to simplify. Stare at it for a second. No, 2 minus p is unnatural and weird, and I'm never going to find a nice reason why it's that. No. Okay. This whole construction is a bit fiddly. Yeah, how did you know it would be an infinite geometric series? Was it the word series? Was it the possibility for this thing to go on forever? The possibility of it kind of continuing to infinity. Was the fact that these geometric multiplication things come up in... they've come up in probability questions before, I think. I'm joking a little bit, Charlie. It's I've seen lots of these probability questions where either something happens or you play again. Like you roll a die, and if you don't get a 6, you roll again. And if you don't get a 6 again, you roll again. And in these ones, the probabilities tends to be geometric series sort of stuff. They do use infinite series quite a lot on this sort of thing. Show that if W is bigger than half, oh my goodness, okay, we're going to do some probability, are we? Show that W is half is if P is less than 1/2. Oh my goodness, okay. Does W increase whenever P decreases? It would sound likely, wouldn't it? The less likely X is to win, the more likely Y is to win the match. I sort of expect that sort of thing to be true, but maybe we could differentiate it or do something fun over there. Can I simplify this a bit? So if I'm now going to do some algebra on this, I'd like to, I think, pull out a factor of, well, P, I think. So this top looks like P squared, bottom looks like P, so I'm going to write P. Now I'm not committed to what this is down here yet. But if I just wrote in a plus and put a nothing up here, I'd get minus P squared, and I would also get 2P. I don't really want 2P, I want 1, so I should write 1 minus 2p. And now everything, if I multiply this back up again, everything would cancel correctly. That would be nice. So be 2p would cancel, yeah, minus p squared. Good. But I can keep going a little bit. I'm going to do a bit more. This is polynomial division. 2 plus 2. and a 2 minus p over here. And if I just wrote kind of nothing up here, that 2 would give me minus 2p, which I want, but it would also give me 4, which I don't want, so I'm going to subtract 3. I think that's polynomial division. Yeah, okay. And that in this format, it'll be easier, I think, to differentiate, at least. Let's answer that part of the question by doing the interesting construction, dw dp. The win percentage with respect to probability, which is 1 plus 3 over 2 minus p squared. Doing that differentiation with the chain rule and getting it wrong because there's a minus sign from the inverse, a minus sign from the p, and a minus sign up front. So the question is that always negative? Hang on. What can I say? This thing, well, let's say this equals 0. This is 0 if, and then doing some multiplying up. 2 minus p squared is 3. 2 minus p is root 3. So p is 2 minus root 3. I'm playing plus or minus, but p is not going to be 2 plus root 3. Which root 3 is bigger than 1, so there is some probability here where it has no derivative. So I think, weirdly, this increases a bit. I think it starts increasing if p is close enough to 1, where this thing becomes really small. So you're dividing by 3. No, that's when you're subtracting a lot. Interesting. Can we Desmos this? Let's Desmos this. Okay. So there's a function in here that I might have just written in wrong. But I'm going to write 1 minus x squared divided by 2 minus x. And I only really care about x between 0 and 1. Interesting. This thing goes up and then down again. That's really interesting. Is that turning point really at x is 2 minus square root of 3? Did I get that right? Yes, I did. Okay. So this says if the probability of x winning is really low, then that's actually bad news for y? That's weird. That's really weird. What's going on there? In words. They're playing this tournament, series of games. And X has this advantage of going first. Well, I guess if X is terrible, these are all less than 1/2. If X is terrible here, X goes first. Oh, but then that's kind of bad news? No. That's amazing. Because it really feels like X just has this advantage where they go first. So it should just be the case that the less likely they are to win a point, then the less likely they are to win the tournament. That's great. That's really fun. So to analyse what's going on there, I think I'd want to look at the probability that X wins the first game. Is this a kind of series thing, or is this X actually having a weird probability of winning the first game, or winning in the first game? So I want to look at these probabilities. I think. Let me type them out over here. Winning the first. P is likely to win the first match. Oh, of course, P is not just a measure of how good X is as a player. It's how good they are to, because whenever somebody loses, they get the kind of advantage on the next point. Okay, I like this. Let's analyze this in chat. Thank you, cool. If P is very small, Y is going to win the first match. But if P is really, really small, then X is likely to win the next match. And then you've said, so Y wins overall. I suppose if P is 1, then they just keep alternating forever. Yeah, so Y's probability is 0. Does it go to 0 when P is... I know, when P is... We're thinking about small p. So I just want to think about this. Chance that X wins the first match, or chance that Y wins the first match? Yeah, let's be consistent. Chance that Y wins this first match, which is B, which I believe is X squared, which is even weirder. That probability peaks somewhere over here. Okay, right, this is just weird and fun. Okay, good. Yeah, they have to win consecutive points. So this situation where in one of the extremes, they just keep trading wins of points. Because X, Y, X, X, Y, X, X, Y, X. And there's kind of a first player advantage in that, I think. X, Y, X, X, Y, X. There's kind of a first person advantage there again. So if it gets into that situation where it's just alternating X, Y, X, if kind of this one becomes extremely likely, or the least unlikely. Do I mean that one? P is very small. Oh no, if P is very small, it's this one becomes really likely. And yeah, okay, let's do some epsilon analysis stuff on this. If P is very small, then this thing's about 1. It's about 1 minus 3 epsilon by multiplying out the binomial. And the other 3 epsilon comes from the next most likely things, which are this one, and there's a couple of others in here, I think, that are not too unlikely. It's this one, XYX in there, and it is, where am I looking for another small, pretty likely thing in here? This thing's also not too unlikely. This is about 1, this is about 1, this is kind of epsilon, if P is about epsilon. I say if P is epsilon, much less 1. Epsilon positive. This thing's like epsilon cubed, tiny, epsilon squared, that's respectable, epsilon squared, not going to happen. That one's acceptable. 1, acceptable, tiny. So in this kind of simplified model, the most likely thing is that you just play another game. But in the other cases, in that one you play another game, in this one X wins, and in that one Y wins, so it seems quite fair. Is that the correct intuition? Yeah, cool. Okay, so over here, we're in the kind of epsilon thing, it's like 50-50. So then the intuition is, why is it bigger than 50-50? Why does Y get some advantage for X being better? That's great. It's increasing. Great, okay. Because, so I've got the leading order there, I need the next order, determine the calculation. So I actually need to look at the win, to get through to this, I need to look at the geometric progression. So it's like the B term in here is like epsilon, right? Is it 2 epsilon? It's like epsilon. And this C thing in here is like 1. So you get epsilon plus. You get packet. Right, never mind. You get epsilon over 1 minus 3 epsilon. That's the probability. Oh no, 1 minus 2 epsilon. Because you get one of these as a rerun. So that cancels a bit and you get 1/2. I want the next order. Okay, I'm not going to calculate the next order. Right, good. Okay, terrible ways of doing the question aside. Good. Oh look, the question actually has some of this in it. What happens when p is 0? So if p is 0, most of these are impossible except the yxy one. So you get yxy forever. Except you cannot win the first game, but then the winner stays on kind of advantage, or the winning the previous round advantage is massive. This looks like just a balance of probability sort of thing. If X wins the match, if so, X winnings. Let's look at the Y winnings or something. Y wins cash now. With probability W, Y wins the match, and so he gives them the K pounds. Probability 1 minus W, minus 1 pound. That's how much cash Y stands to gain. So we want something like KW is supposed to be equal to 1 minus W for to make it fair. So evaluate W when P is 2/3 and do some division, I think. Easy peasy. Good, right, cool. Done a question. I'll call it there, I think. Let's have a look back at vectors before we wrap up. Is this a better vectors question? That's more of a way of making a point. No. Some of the mechanics questions, this is from 2011, so pinch of salt, but some of the mechanics questions on STEP are just vector questions. And that makes it fun. How fun does this look? Not that fun. A bit fun. Vectors, vectors, vectors. 100% vectors. No geometry. Good. Excuse me. Let's see if we can salvage this mess. So we had some diagrams which weren't really doing anything, so they can go. We had this thing at the top, which was only okay, and I'm not even sure I want that diagram. We had some highlighting down the side. We had, that's copying out a line that's in the question. That's what it means to be collinear. We've got some maths over there. We've got a messy expression in here and some more underlining. We know what C is, and we got down to this expression. Right, we're going to jump back into some vectors. So we go. Twitch says my connection is unstable and stuff, so fun. I'm going to ignore Twitch. I'm just going to just vectors. And also, this is controversial, but I'm going to put a big square over this. Like this. With no edge on it. And I'm going to copy the square, put another one over here. And ta-da, I've gained extra writing space. In the actual test. In most actual tests you get something to write on that isn't the question paper with no spaces in it. That seems to be what I'm doing today. Okay, right, nice fresh start. In the case that lambda is -1/2, we're going to determine the angle AOB in the form of determining its cosine. This makes me think, by the way, that its cosine is something weird. Otherwise, they would say determine the angle. If it was a cosine we recognised, we would say what the angle was. Anyway, describe the relative positions of A, B, and D. Oh, that bit we've done. If it's just A, B, and D for the description, we've done. D turns out to be the midpoint because lambda is -1/2, so that's 1/2 in here with the minus sign. And mu is also 1/2, so this D is the midpoint of A and B. Okay, so we've kind of done that part. We've just got to determine the cosine of AOB. And I really want to look up, I think, to look back at what we were doing. One more shot at messing around with the lambda. It's more likely than you might think. Yeah, let's try mu. Let's go for mu. Some work on mu. Which was kind of a rehash of how reflections work. Changing all the letters, if I remember correctly. There was a step in here where it was like minus lambda A, but then plus another B. So you get this plus 1. It was 2 B dot, and I'm going to be really careful this time round. Minus, and then B dot B over B dot B. So there's going to be minus 2, but then plus 1. Okay. Okay. So we're now told this was always true, that mu minus 1 would be this thing. And we later discovered that lambda plus 1 was equal to mu. So we have this expression for lambda up here, and this expression for mu down here. We discovered along the way that lambda plus 1 is mu. Yeah, it's kind of 2 facts. No, we know the precise values of lambda and mu now. It's really good. We know that lambda is minus 1/2 and mu is 1/2. And that kind of captures this fact that mu is 1/2, captures this idea that D is all this stuff about A, B, and D being collinear. That gives me this mu is 1/2 fact. So I don't have to worry about that anymore. I've used that fact. And this mu fact, if I get this right, in terms of the lambdas as well, then that'll be enough to make sure that D was the reflection of C in the line through O and B. And if I get this mu fact, then that's enough to tell me that C was the reflection of B in the line through O and A. But I think that's all I know. I guess that O, A, and B are not collinear. I think I've used that along the way as well. Okay, so if I plug these in, I get 2 expressions, and I've seen them already because they're not very complicated expressions, but I'm going to write them out one more time, damn it. It's minus 1/4 from dividing by 2 over here. A dot A is equal to A dot B. And this mu1 over here tells me that A dot B over B dot B, minus sign, minus 1 is equal to 1/2. These are not the numbers I had before, so that's good. That's just great. Why not? Because look at this working out, it's a mess. Look at this working out, it's a mess. No way that's going to give me the right answer to anything at all, is it? Yes, I've lost this minus 1. Sloppy. Sloppy and wrong? Yeah, I should have added a 1. Anyway, okay, this was all still wrong, including all that root 2 stuff. Really sorry about all the root 2 stuff. Okay, so A dot B is also equal to minus 3 over 2 B dot B. So that gives me a relationship between the lengths of A and B, which is now making me feel like equilateral triangles and things. Can I just multiply them together? Who's going to stop me? Who's going to stop me to multiply them together, right? Yeah, I'm going to multiply them together. I'm multiplying them together like this. I'll get loads of minus signs, but I'll get a 1/4 in there, I'll get an A dot A, I'll get a 3 over 2, I'll get a B dot B. The minus signs cancel. On the left, I've got mod A squared, I've got mod B squared, and I've got cos theta squared. Oh, I've got a value. I've got a value for cos theta. I think I'm done. Do I want plus or minus? Definitely minus, because cos theta a dot b is negative. Okay, that's mad. I may have to draw this in Desmos. Okay, we got a number. I had two equations. The trick was to multiply them together and get all the numbers right. Okay, vaguely happy with this. Something about 15 degrees, maybe? Let's Desmos. Let's try and build this. Time check, 20 minutes, let's go. Zoe says, if you get accepted by your first college, is there any way of finding out what your second college thought about you? This is an Oxford admissions question. This is my job. So if they've stored any comments, then that's personal data that the college holds. I think technically both colleges have access to it. So if you ask for interview feedback, then or more specifically, if you ask for any interview comments to either college, you could write to either of the two colleges in this situation. And then I like the idea that you've used some giant holy spreadsheet. This is my job. It's not a spreadsheet. We have a proper database for this. But yeah, an Oxford Maths Admissions runs on a big database where all of the colleges can see all of the applicants and can enter comments on interviews. So in some sense, those comments are stored in a big central database. But college, if you ask them nicely, and if asking nicely doesn't work, remind them about data that they store on you. Haven't got interview feedback. Huh. Did you ask specifically for interview feedback, or did you ask for admissions feedback? Because if you just ask for admissions feedback, some colleges interpret that as quite a general thing. Thank you for the follow, Wazaz. A large boardroom. Right. So a large boardroom with lots of paper applications. There's not the Oxford way. Cos. What do I want? I want to set Desmos to degrees for starters. How do you do arc cos in Desmos? Why am I using Desmos rather than a calculator? I didn't know, it just felt correct at the time. Oh, is that nice? It doesn't look nice. That's not nice at all. Why did I think that would be nice? Interesting. Let's put the minus sign in as well, why not? Let's give it a name. That doesn't look that nice at all. And importantly, I'm going to call that B or something. Okay, so what do I think is going on here? I've got some relationship between the length of B and the length of A. I'm going to set A to be the point 1, 0. I'm going to try and draw the diagram. The diagram that I couldn't draw at all earlier. And I'm going to try and draw the point. So, what do I know about this point B? I know its length, and I know its angle with respect to... Its angle with respect to... Angle with respect to that. Because I know mod A and mod B are related like this. Minus 1/4. A squared is minus 3. And I'm sorry that I've had about 4 attempts at writing down this relationship. I'm not even sure about this 3/8 thing. No, I am sure about the 3/8. Okay, no. Squared is 2, 4, 6. Good. So I want mod B to be like 1/√6 times the length of A, which for me is just 1. So divide by that √6. Why is it not happy? Too many variables. Would you prefer it if I gave it a silly name like Q? Would that be happier? Okay, because I prefer to type Q as well. Okay, I believe I've got the points A and B lined up. Next step. We have some expressions, right? So we know that lambda, I can't do lambda, okay. Lambda is minus 1/2. And we know that mu is positive 1/2. And we know that C is supposed to be lambda A minus B. So hopefully I can just do this. Lambda A minus B, and that gives me C, which is the reflection, so that's nice. That is definitely the reflection of B through the line through O and A. And then for my final trick, I'm supposed to reflect this through, oh my goodness, through, where's this going? Through the line through O and B, but I actually know an expression, right? I know that I should do mu times A minus lambda times B, which can be the point D, which does look like it might be the midpoint. A, B, and D might be collinear. Yeah, it might be collinear on that segment. And then I think I want to draw in this line through the origin and B, and kind of want to extend that line a bit, but too lazy to work out where it is. Yeah, because this is going to reflect over there. This is mental. Look at all this. Is there no nice expression for this number here? Let's go math hard. That's not right. 2.23 radians. Over there, says Wolfram Alpha. Huh. Exact result. Thank you, Wolfram. Great stuff. Okay. I think we need more digits here. Let's have another look. Yeah, more digits. Yeah, thanks. So you get plain text. Is it giving me twice as many digits each time? Yeah, there we go. Yeah, that's what we needed. Ah, with a 6. I thought that'd be 7. Okay. Wow, what a weird triangle. What a weird step question. What a weird stream. What a weird idea. Talk about a geometric sequence. Yeah. I see. Yeah. Part of me read that and thought that was a request for content. Talk about a geometric series. Any of them. Anyone. Choose your favourite. There's a danger that I now get too carried away and try and do another question. I don't want to do any of these mechanics things. Some of the mechanics ones, right? Some of these have infinite series in as well, right? See if I can even work out what's going on in this question. I've got 10 minutes. Straight line and smooth horizontal plane. If they say plane, I reckon it's going to be 1D. Speeds 2u and u respectively. Okay. A has got mass 2m and it's going at speed 2u. B has got mass m and it's going at speed u. They collide. Okay, easy peasy, 8 level sort of stuff. Work out what's going on afterwards. So you have to know what coefficient of restitution is. But one of the things I like about the mechanics question or step is if you don't know what coefficient of restitution is, you know when you read the question, you read this much of it and you think, this is not for me. When you read the pure maths questions, you have no idea, right? It could turn out to involve an arc cosh at any moment. Whereas this one, no. Yes, the digits. Right. That was actually a very good joke, Charlie. I'm sorry. Okay, well, what are we doing? B's going to collide with a smooth vertical wall. So it's like that 1 3 blue 1 brown video. After the collision, the B's going to collide with a small vertical wall. There's a wall over here. Rebounding and colliding with A for a second time. For a total of 3 bounces. Which, that's almost exactly the value of pi. The coefficient of restitution between B and the wall is F, where F is like this. Oh my goodness, do just another bounce. The wall has infinite mass and no velocity. We're not in a closing wall situation. Yep, that's right, Zoe. Separation of velocity divided by collision velocity. Or possibly, yeah. If you're in a more complicated kind of snooker situation, then it's only the normal component of the motion that we're talking about for that separation velocity and approach velocity. Bouncing things is actually really complicated if they're going at different velocities in 2D. I haven't really thought about this properly. I realised I was about to say what the other part of it is like, but I'm just wrong. I was going to say the other bit doesn't matter, but it kind of definitely does. There's some interesting effects, I think, from one of them, the kind of motion along the plane. It's just excited, right? Pi. It's got collisions in. Must be pi. Possibly 100 times pi. 314. Is it 314? No, it's just this velocity, which is I minus 4e squared fu. Towards the wall, and B moves towards, not away from the wall. For all values E and F. Oh no, it's going to have a fourth collision. Oh. Okay. The velocity of the ball. So then it's the question would be to show that this is positive at the end, which does not look like fun. Really not fun. For all values of E and F in those ranges. So it's like is 2, 1 minus e squared u minus 1/3, 1 minus 4e squared f positive. I've removed the 3e factor. And I guess I can remove the factor of u as well, because u is positive. So inequality time. That's like asking, is this thing positive? And maybe I stand a chance at that question. Maybe. Not super jazzed. I guess 4 is much bigger than 2, so maybe we could get lucky with that. 2 minus f minus 2e squared. I'm just trying to do the last part of this question to see if it's fun. And what have I got? Not a lot of hope here, I think. Yeah. Wait, no way was it the difference of 2 squares? There's a 2 in there and a 4. Oh, if I've missed the difference of 2 squares, that'll be very sad. I think the f throws things off a little bit. An f in here. I don't know which of the squares to put that in. I guess f is positive, so it's the square of something. It was a quadratic. This is a quadratic in E. It's a linear in F, but it's a quadratic in E, right? This is a quadratic in E. So there's a question here about like whether this quadratic has any roots. Maybe I should complete the square on this quadratic. For F, this is kind of surreal. Why is there a complete the square in my mechanics question? Why am I so bad at completing the square? Am I stalling for time? You bet. Am I getting the complete the square wrong? You bet. Okay. So it's e squared coefficient. It's 4f minus 2. That's positive, right? Oh no, that could be negative. Didn't ask that. This is an unhappy quadratic. Oh, that's fine. We'll deal with that in a second. This is maybe a stupid idea, though. Yes, this is a stupid idea. I think I'm just getting stupider and stupider. Which is not a pleasant feeling. know what I'm doing anymore. I was going to complete the square, and then I realised that would be really daft. So I think I've given up on completing the square. Right, if they're both 0, you get the number 2. So let's try and prove that it doesn't go too wrong from there. Anyone in chat got any ideas for how we might prove this is positive? Feels doable, but I'm struggling a bit because of this minus 2e squared. Which is like, if e gets quite large, then that's really minus 2ing. If e's quite small, then I'm worried about this 4e squared minus f over here. Maybe I do just complete the square. I don't want to. Okay, let's write it out like this. 4f minus 2 e squared plus 2 minus f. So there's kind of two cases that I can think of here. This 2 minus f is always positive. I've zoomed way in, so I should check before I zoom in way in that I've got all the coefficients right. This 2 minus f is always positive. So this is either going to be a quadratic like this, in terms of e, feels weird putting e on the axis, or it's going to be quadratic like this, which might come down fast enough in time to give me problems over here. So I should check, where is this 0? Okay, yeah, let's check where is this 0. I've really forgot, like, this is 0 if e squared is f minus 2 over 4f minus 2. What? Right, so then the question is that between 0 and 1? This is going to hit 0. Is this thing less than 1? And once again, I'm running out of space. And there's kind of two cases, depending on f relative to 1/2. Can I just evaluate it at e equals 1 and see what happens? See what's the value when e is 1, because that's the bit I care about. This is quadratic going up, and that's fine if f is bigger than 1/2. If f is bigger than 1/2, this is a happy quadratic, and it'll just go whoosh upwards. If f, so this is f bigger than 1/2, and over here this is f less than 1/2. Its coefficient is negative, and we come down. So I should check what's going on at e equals 1, but at e equals 1, so forget all this. At e equals 1, I get the value of 4f minus 2 plus 2 minus f, which is 3f, which is positive. So this thing hasn't made it down to 0 yet. So it's never 0. So it's always positive, because the quadratic that has positive values never makes it down to 0. Cool, right, good. So whether or not I can do the A-level questions of everything bouncing off everything else, I think I will leave as homework for you to bounce things off each other. I made a meal of that inequality, right? Turns out completing the square was a sensible idea, except it didn't take very much completing because there's no e term, only e squared. No e, only e squared. Sum of 2 squares in the end. Well, almost difference of 2 squares, isn't it? I eventually take the difference of the terms. I'll go with what Charlie said, gosh, about 10 minutes ago. That was the step stream. I think I'm going to wrap up in a second. So, what am I leaving you to do as homework? If you're interested in step questions, then maybe not so much this mechanics and stats question, but look how much more progress I made with the mechanics and stats than I did with the probability. I can't remember if we talked about this question last time. Maybe we talked about this question and then I forgot all about it. But I think this question is good. So I would quite like to talk about this one at some point. Maria's asked a very good question in chat, which is, what on earth am I doing next week? I think I am around next week. I've had quite a few weeks off recently for various travelling and seeing people. But I think I'm back. I haven't done this one. This one's great. I did a bit of this when I was setting up the board, and I couldn't remember if I talked about it live or not. So if you want the sum of some... By the way, Charlie, if you want the sum of a geometric series, here's another one. Look, all these things have got lambdas to the ends in, and we're going to add them. We're going to add them up. Partly using the fact that we know what lambdas are, and we know how to add together these geometric series. Charlie forgot to say something, so I'll let Charlie say that while I do some half-hearted adding together geometric series. Where did I get? So I think this is just how geometric series you might expect it to work. You get kind of the next one up. Charlie, yeah, okay, yeah. A teacher's invited me, and then I made some arrangements for end of May. I'm getting a couple of trains. That's happening. Oh, okay. I didn't realise when that came through. Sometimes when the teachers email me, they say, this person in our maths club who had saw a stream and then wanted an Oxford Maths talk. Yeah, this time I just did that. Cool, right, okay. See you end of May. But I'll see everyone quite soon. Geometric series personality. Yeah. Okay, advice for this question, if you're trying this one at home, and if you want to find it, it is Step Paper 2, 2011, question 7. Advice for this question. It took me ages to realise that bn squared, if you square bn, you get a mess, right? I'm going off the edge. If you square bn, you get a mess like this. It took me absolutely ages to realise that lambda mu is something I know about, because I know the value of lambda and I know the value of mu. It took me absolutely ages, and it's not the sort of thing that I would recommend overthinking too much. Because it's the difference of two squares and it's a variation of 1 plus 1 is 2. So it's all of the catchphrases all at once. But, minus 1. So should have spotted that much faster. These streams are useful for me learning to do step questions again. After, 15 years out of the game or something, to learn to do step questions again so that I can maybe be a bit helpful with people getting ready for step. But maybe not yet. So maybe not helpful yet. We'll get there. Horror of vectors. Was that horrible? In hindsight, I did simple stuff, and then I started making loads of weird algebraic mistakes around here. I think I just sort of lost confidence in what I was doing and my ability to do it. I also moved to a very narrow column. Maybe I should avoid that. That's something I can actually do, so I'm going to avoid narrow columns. Maybe I'll do that in real life as well. And I think I was trying to solve for the size of A, the size of B, and the cosine theta. I think at one point I said I had 3 unknowns, and that was silly because I'm never going to determine the scale of this picture. It's all reflections, and those work at any scale. So I'm never going to work out mod A, mod B. So I should have realised that instead of rearranging all this stuff for mod A and mod B, I'm never going to solve for those. So I should be trying to eliminate them. And I think if I'd been thinking about eliminating way back over here, so instead of rearranging this, if I'd had this and I had this, okay, I had to do some work to get down to have that in terms of B dot A as well. But if I'd been thinking about eliminating A and B, mod A and mod B, then I might have multiplied them together much quicker. So hindsight is, for me, that this is no scale or orientation to this particular geometry problem. By the way, if you're still thinking about doing this question in coordinates, this is kind of killer for doing it in coordinates. That you need to choose an orientation when you set up your coordinate system, and you're probably going to end up choosing a scale for things, or you're going to have lots of factors in there, lots of extra letters that don't matter. Kind of one letter representing a global rotation of the whole problem. In Desmos, I chose to set it up when we did the Desmos sketch. I chose to set it up along the x-axis, but if you don't make that choice, then it could be anywhere. It could be any size as well. And vectors are sometimes good at hiding that, but maybe I also need to remember that I've hidden it to sort of minimize the thing about scale and orientation, but maybe remember my intuition that could be some scale in general. Advice for actually doing the step. Exam technique. I think switching questions is key. We saw it a bit here. It works today, so I think I'm going to recommend switching questions when you get stuck, switching between different questions. I think that's going to be a takeaway as well. I was a bit too proud to switch for a long time. Need to learn from that. Okay, 3 takeaways. Did I have 3 takeaways last time as well? Can't remember, can't find them. If I had any takeaways from last time. Oh yeah, look. I can solve cubics and focus on the division because I think I got it wrong. Okay, I'd like to get some takeaways from what I was doing. There's definitely a takeaway over here. Where's it gone? Oh, this was dismal. I spent so long dividing numbers incorrectly. Like just normal numbers, rubbish. Switch questions. I'm going to lay my work out more widely. Wider layout. That's a vector specific thing. Okay, I'm back next week. There's a request to just do chill maths next week, not do any step. So we'll see. If I've got a good topic for some chill maths, I might focus on that for a bit next week. Otherwise, I'll see some of you on Thursday for Maths Club, if you're around for professional live streams. I might see some of you on Saturday for a virtual open day, if you're in roughly year 12 or equivalent around the world, thinking about applying for university later on. Maybe doing that. Is that a suggestion to do Murderous Maths? The book Murderous Maths? As a topic. Bye, Gabriel. Right, cool. Okay, take care, everyone. I never really know how to finish the stream, so I'm just going to... Oh, the website. There's a website? 2 seconds. Yeah. I grew up on these books. Oh, there's a website and it looks a lot like a website that might have existed since I was a child. Sorry, Sharton. Yeah. Haha, foolish youth. The teacher is also the puzzle. What? Oh my goodness. Slightly wobbly page. This is lovely. There's a USA visitors page. I like this website a lot. Right, cool. Maybe this is the chill maths next week. Nice. Right. Take care, everyone. Thanks for the follows. See you next week.